Okay, let's start talking about solving rational equations. So on the left, we have a rational equation that we're used to dealing with, and these are just basic fractions with numbers in one variable. So 2/3 minus x fifths equals 4/15. So we know a way of solving this. We know that when we're adding and subtracting fractions, we can only do that, we can only add or subtract straight across when they all have the same denominator. But an even easier way of solving this isn't putting them all in the same denominator, but actually removing the denominators altogether, eliminating the denominators. So what I'm going to do in order to do that is multiply by the common denominator of all terms. So I see 15 right here, and I know that 15 is 3 times 5, and my other denominators are 3 and 5. So I know that if I multiply each term or the whole entire equation by 3 times 5, I'll be able to clear all the denominators. So we call that clearing all the denominators. So I'm going to multiply each term by 3 times 5, by 3 times 5, and by 3 times 5. Okay, a little bit messy, but now I can start to cancel some things out. So in this first term, the 3 on top and the bottom will cancel out, and I'll be left with 5 times 2, which is 10. In my next term, the 2 5s will cancel out, and I'll be left with 3x. And then my 3 times 5 will cancel out with the 15, and I'll be left with 4. I'm going to subtract 10 from both sides. Negative 3x equals negative 6. I'll divide by negative 3 on both sides, and I'll get that x equals 2. Now for this, I can go ahead and check my answer by plugging in 2 into the original equation and seeing if I get the right answer, or seeing if both sides of the equation match up. In order to do this, now I do still have to work backwards, and I'm going to multiply by 5 over 5, so I get the denominator of 15, and I'll multiply by 3 over 3, so I'll get the denominator of 15. I'll get 10/15 minus 6/15 equals 4/15, and if I solve all the way through, I see that this is a true statement, so x equals 2 is a solution to this equation. Now, I'm going to do the same thing on the equation on the right side. Same exact thing. I do have a few things I need to pay attention to, however. Since I see these are polynomials on the bottom, my first step, I'm just going to factor any denominators that I see that I can factor. So that leaves me with just this x squared plus x, which I can factor into x plus 1. This makes it easier for us to see what are those factors in our denominator. Okay, so now I need to remember, okay, we have some fractions where we have variables on the bottom. That means we'll have some domain restrictions. So I can already see what we know about domain restrictions. I can already see I cannot have x equals -1 or x equals 0 because my function will be undefined there, or my equation, those fractions will be undefined. Okay. So now I'm going to move on. I kind of added 2 steps in there, right? I factored all my polynomials on the bottom, and I looked for domain restrictions. Okay, so now I'm moving on to the next step, where I'm multiplying through by the largest common denominator of all terms. So that would be x times x plus 1. So I'm going to go through and multiply all my sides by x times x plus 1. Multiply up here, x times x plus 1. I'll multiply over here, x times x plus 1. Okay. I'll see here my x plus 1s will cancel out. I will be left with 2x. I see over here that actually my x and my x plus 1 cancels out, and I am left with a -1. And over here, I see that my x cancels out again, and I will have to distribute that 3. I'll be left with 3x plus 3. I can continue to solve, so I'll subtract 2x from both sides and subtract 3 from both sides. I will be left with x equals -4. Okay, so I'm comparing -4 with my domain restrictions, and I notice that it's not one of my domain restrictions, so I should be fine. To double check, I could plug -4 back into my equation, just like I did on the left side, and make sure that it checks out. Okay, now we're working with something a little bit more complicated looking, but you can handle it. So my first step, I'm going to go through and factor polynomials. Factor all polynomials. That's my first step. Okay, so I see I can have x over 5 times x plus 1. I cannot factor x plus 2. That's already kind of in a factored form there. And then I'm going to go ahead and factor this polynomial. I can see that I'll have x plus 1 times x plus 2. Okay, so now I can kind of sort out my domain restrictions. Domain restrictions. So I can see that x cannot equal -1 and x cannot equal -2. So I need to pay attention to this in my final answer. But I'll put that on hold for now, and I'm just going to go through and do what we call clearing the denominator. I'm getting rid of the denominator by multiplying by the greatest common factor of all the denominators. So I see that I have x plus 1 as a term, x plus 2 as a term, but I also have this 5. So I'm going to multiply the whole equation by 5 times x plus 1 times x plus 2. So for us, clearing the denominator here, clear the denominator. We're going to multiply the entire equation by 5 times x plus 1 times x plus 2. Okay, so here we go. 5 times x plus 1 times x plus 2. And I have my x, and I have my 5 times x plus 1 in that fraction equals, and then again I'm going with 5 times x plus 1 times x plus 2. And what I'm left with here, my 1 and x plus 2. Okay, again, I'm multiplying everything by 5 plus x plus 1 times x plus 2. As you keep doing this, you'll kind of see some shortcuts you can start taking, and you won't have to write this out every time. Okay, so now I'm going to go through and cancel things out, and this will work very nicely. So 5 cancels out 5, these cancel out, my x plus 2's cancel out, here my x plus 1 and my x plus 2 cancels out. I'm going to kind of clean this up, and I'm left with x plus 2 times x, so I'll distribute that, x squared plus 2x. On this side, I'm left with 5 times x plus 1, so I'm going to go ahead and distribute that as well. And over here, I'm just left with 5. That's super nice. I'm going to go ahead, this is going to be a quadratic because I have this x squared here, so I'm going to move everything over to one side. X squared, I'm going to subtract 5x from both sides, and I'll get -3x. Oops, and then I'm going to subtract 5 and 5 from that side, and I will get -10 equals 0. Can we factor this? Do we need to use quadratic formula? I think we can just factor it. X minus 5 times x plus 2 equals 0. And I get that x could equal 5 or x could equal -2. Okay, we do have x equals 5. It doesn't match any of my domain restrictions. However, we know that x cannot equal -2. So x equals -2 is not a solution. Only x equals 5 is a solution to this equation. Okay, here we go. We've got another one. So again, my first step is to factor. I can factor the top if I want to too, because there might be things that cancel out, but I'm not going to this time. I'm going to look at that denominator, and I see that I can factor by parts, factor by grouping. So I can take x squared out of the first two terms and be left with x minus 4. And I can take 3 out of the next two terms and be left with x minus 4. Okay, so this is the same denominator on both sides. So I'm just going to keep simplifying that, and I'll replace it at the end so that I'm not doing it twice. So I have x squared plus 3 times x minus 4. Okay, before replacing that and solving for everything, I do want to find those domain restrictions. So I know that x cannot equal positive 4 based on that factor of x minus 4. And then I've got to solve for x in this other factor of x squared plus 3. So I'm going to go ahead, x squared plus 3 equals 0. That means that x squared equals negative 3. I'll take the plus or minus root, and I'll get x equals plus or minus square root of negative 3, which I will rewrite as root 3i. So I know that I can't have x equals 4 or x equals plus or minus root 3i. So those are my domain restrictions. Now I'm going to come back over here and rewrite this using my factored domains. Okay. Sorry, my factored denominators. I see that I need to multiply both sides of the equation, the whole equation, by x squared plus 3 times x minus 4. It's going to cancel out on this side and on this side, and all I'm left with is 3x minus 6 equals 4x plus 1. Okay, let's just keep solving. Negative 7 equals x. Perfect. That is not part of my domain restriction, so I know that this is a solution to my equation. All right, so this is where it starts to get a little bit funky. I'm going to see if I can cancel things out first here. So I'm just going to factor everything that I can factor. And again, I am going to remember my domain restrictions, but let's go ahead and figure out what we can factor. The top, x to the 4th minus 16. That is a difference of squares. That is x squared squared minus 4 squared. So I know my factors there are x plus 4 times x minus 4. Oops. Sorry, I know my factors are x squared plus 4 times x squared minus 4. I can see the same thing happening with the other numerator. The 6 squared minus x squared squared. So I know I'm going to have factors of 6 minus x squared and 6 plus x squared. Okay. I still have my x squared plus 4 on the bottom and x squared plus 6 on the bottom. Those are not factorable. We will get imaginary numbers if we try to find the roots here, so those are not factorable. So I'm not going to bother factoring them. I am going to find my domain restrictions. So I could solve this all the way through, but I'm just going to set them equal to 0. And I see that I'm not going to be able to have the plus or minus 2i. So I would just do that by solving for x squared plus 4 equals 0. And same thing with x squared plus 6 equals 0. I would get that I can't have the plus or minus square root of 6i. Okay. Now I'm going to go back to my function, my equation. These cancel out, and these cancel out as well. So I don't even need to bother multiplying times everything because that would just add so much more into the equation. I've just gotten rid of my denominators by canceling out factors on the top and bottom by simplifying. So now I have x squared minus 4, equals 6 minus x squared. It is true that we could factor these more because these are still both differences of squares. But I can already see that I'm solving for x and some of these things are going to cancel out. So I will add x squared to both sides and add 4 to both sides. We'll end up with 2x squared equals 10. I will divide by 2 and get x squared equals 5. and I'll take the plus or minus square root and get that x equals plus or minus root 5. Now that is not one of my domain restrictions, so I know that x equals plus root 5 and x equals negative root 5 are solutions to my equation. Okay, 2 more to go. Only 1 more to go. So now we've got these differences of cubes I see on the left-hand side. Again, I'm going to kind of go through and factor what I can and cancel things out and work on my domain restrictions at the same time. So, actually we can work on domain restrictions first. We can always do that first. If I set 19 minus x cubed equal to 0, I will get that I cannot have x equals the cubed root of 19. Then I'm also going to set 7 minus 2x minus x squared equal to 0. Now, I'm not going to solve this for you because you know how to use the quadratic equation. I am going to get something funky like x cannot equal the plus or minus, maybe 1 plus or minus root 1 plus or minus 2 root 2, I believe. So those are my domain restrictions here. Okay, now I'm going to keep going with the factoring and the solving. I can see that this is something that will cancel out, so I won't want to bother with multiplying by a common denominator. I'm going to want to cancel those out first, so I'm multiplying by smaller polynomials. So I can see if I keep x cubed minus 19 on the top, if I factor out a negative 1 on the bottom, I will have x cubed minus 19. Those cancel out very nicely, and I'm left with negative 1 on that side of the equation. Now, I know that the bottom doesn't factor out because I just found my, my really crazy roots from using the quadratic equation. The top does factor out, but it really doesn't help me here because there's nothing I can cancel it out with. So I'm actually just going to bring it down and leave it in non-factored form. And I've got this nice equation. Okay. I'm going to do what I said before. I'm still clearing the denominator. So I'm multiplying both sides by my denominator of 7 minus 2x minus x squared. 7 minus 2x minus x squared. Okay, they will cancel out nicely on this side. And on the other side, I have to distribute that negative 1. So I'll get negative 7 plus 2x plus x squared equals x squared minus x minus 8. Here we go. I'm subtracting x squared from both sides here. I'm just solving for this. I'll get 0. 0 pairs. I'll cancel out, and I'm left with my x's and my integers. So I can add x to both sides here, and I can add 7 to both sides there. What I will get is a nice 3x equals 15. I can divide by 3 and get x equals 5. All right, that is not one of my domain restrictions, so I know that this is my one solution to this equation.